So they represent the motion of four cars on a straight road. So we have on the graph, it's a speed time graph. It's a speed time graph. So on the graph, we have car A, B through to D. And the speed time graph for each one of the cars is nicely drawn on the graph. Question 1. The speed of car C at time t is equal to, so we are looking at the speed of car C at time t is equal to 20 seconds. Okay, 20 seconds. At time t is equal to 20 seconds. Okay, it's close to 1, we have 60, 45, 3, and then 600. Yes, what is your take on this question, class? I said this, the speed of car C at time t is equal to 20 seconds is close to, yes, it's close to what? Ablina, is that the speed is close to what? Class, can you hear me?
Yes, please.
Give me feedback. The speed is close to what? Is it 60, 45, or 3, or 600 from the graph? Yes, Michelle.
60 meters per second.
Yes. When you look at car C, its speed is not even close, but from the graph it's exactly 60 at the said time. Okay. Now, let me add this. For car A, at a time t is equal to 20 seconds, its speed is equal to, for car A, I'm chipping in for car A. For car A, at time t is equal to 20 seconds, its speed is equal to what? Yes, anybody to try? Car A. We've just discussed for car C, and I am including car A. Its speed at 20 seconds is equal to what? Yes, anybody? Michelle again. If nobody is talking, then Michelle, or Gideon wants to try. Okay, Michelle, let's hear from Gideon. Gideon.
20 meters per second.
At time equal to 20 seconds. Look at it again. The speed of car A is that equal to 20? Anybody? Gideon, mute yourself. Michelle, are you there? Michelle, are you there? Oh. Gideon again. Gideon, go ahead. I'm listening.
Sorry.
Oh, so Benjamin.
Yeah, please, the question I didn't hear so.
My question is that what is the speed of car A at time t is equal to 20 seconds? Okay, Ablina.
Sir, please, 20.
No. Oh, okay. All right, I get you. Ablina, you are. Oh, then that is what Gideon said earlier. Yes, it's true. It's 20. I thought The horizontal line is 0. Gideon, you are right. Okay. So it's 20. All right. Then question 21. Which car has 0 acceleration? Which car has 0 acceleration? Yes. Paddy.
Tabi.
Car B. Yes. Okay. So once it's a speed time graph, if the gradient is 0, it means the acceleration is 0. 22. Which car is decelerating? Which car is decelerating? Anybody? Frank. Frank. Oh, Frank's concentration. Okay. Paddy. Paddy, 22.
Car A.
Car A is decelerating. How would you describe this as deceleration of the car? Is it uniformly decelerated, or how would you describe the deceleration of this car? Frank, I call you, but the feedback is not good. Frank.
The car is non-uniformly decelerating.
So this is a non-uniformly decelerated motion. Thank you. 23. Which car moves the greatest distance in a time interval t is equal to 10 seconds and t is equal to 16? Which car moves the greatest distance in the time interval set or given? T is equal to 10 and 16. Yes. Anybody? Anybody? Yes, Amelda.
Car B.
Amelda, what's your reason?
Because when you check the intersection for the 16 seconds, you see that car B is on top of all the other intersections for the other cars.
I didn't see why.
Well, anyway, that is Emelda's point of view. More views. More views. Giovanni's hand is up as well. Okay, Giovanni, hold on. Let me talk to Sidel and come back to you. Sidel, what is your take on this question? Which car moves the greatest distance in a time interval 10 to 16? Sidel, are you there? Okay, then Giovanni, take over.
Sir, please, car C.
Why? Why do you think it is car C?
Sir, please, because car C started from the like where the 10 was, the points they started from there, and it accelerated to another point in a uniform manner. So in the line 2 is also straight going upwards.
All right, very well. But I beg to differ. More views. More views. Okay, class. The car which moved the greatest distance in the time interval 10 to 16 is car A. Ask me why. It is car A because I said for velocity or speed time graph, the area under the graph is equal to the what? The area under the graph is equal to what?
This time.
the total distance traveled. So if the area is large, we'll have a larger distance. Now look at, you see, the question refers to a certain time within a certain time interval. And that is from 10 to 16. So all graphs must actually end at 16. If you look at car A, okay, its curve where they all intersect must be on a 16. So it's like, if this is 16, if they are all intersecting here, and you look at the shape of A, it's a non-uniform motion like this. So it means that this area under the graph, the larger the area, the larger the distance that would be covered. Whether it's a decelerated motion, zero acceleration, or a decelerated motion. So when you compare all of them within the said time, that is the one with the larger speed. Look at C for instance. C starts from this point, though continuous, but we are limited in the time. So the area under the graph for C would be just this, the area covered. And so this is the area. That of car B will be a rectangle, okay? So the area under the graph is the total distance. So it is obvious car A has a larger area compared to all of them, considering the time interval that is stated in the question. Class, are you okay? Class, are we okay?
No.
So Marilyn, the whole argument is that the area under the graph would give you the total distance covered. The larger the area, the larger the distance traveled. So when you look at all the cars, A, B, C, within the time interval 10 to 16, the area under the curve for car A is the largest. The area under the curve of car A is the largest considering the time interval. All other areas under the line or under the curve is lesser than A, car A. And once the area is greater, it means that distance covered would also be greater. So this is actually by visual inspection. We can calculate it, but you can easily determine this using visual, your eyes, just to check. Marilyn, are you okay?
Yes, sir.
All right. 24. Which graph best represents Caleb? Please mute yourself. Which graph best represents the relationship between distance and time for car C? Which graph best represents the relationship between distance and time for car C? Benjamin.
Please, graph C.
Benjamin, what is your... Oh, we have numbers. Please use the numbers. 1, 2, 3, 4.
Sir, please, graph 3.
What is your reason? What is your reason for choosing graph, the third graph?
I'm not talking about
Gerard, your hand is up. What is your take?
Graph 3.
What is your reason? Ferdinand, please mute yourself. You are not talking.
It shows a straight line with a constant positive slope, indicating a constant speed as the distance increases steadily with time.
Okay. All right. Let me add my voice. You are correct. The explanation in line, but let me add mine. You see, graph, the motion of car 3 is a uniform accelerated motion. It's a uniform accelerated motion. And in a uniform accelerated motion, the body moves with equal speed or velocity within equal time interval. So maybe from t values 0, 1, 2, 3, 4. The speed or velocity of the body is 0, maybe 2, 4, 6, 8. Meaning the body is moving with equal speed within equal time interval. So at every time, the speed is uniform or constant. If the speed is uniform, then to plot this on a distance time graph, it must be a horizontal, a straight line like this. So it is this because, or maybe starting from a certain initial distance like this. So it is just because at every time that the speed of the body is constant. So if the speed is constant, then it can be plotted on a distance time graph as this. Hence, the graph 3. Any question? No question. Okay, let's look at the other. So in the other graph, we are told to base, the instruction is always very important. Base your answers to questions 23 to 29 on the 4 graphs below, which represents the relationship between speed and time of 4 different objects A, B, C, and D. Which object is slowing down? Once we've answered the first part, we must quickly go through this. Marilyn, which object is slowing down? Marilyn, 25. Marilyn, are you there?
Sir.
Oh.
Sir.
Talk to me. Oh, Marilyn, you are here.
Yes, sir.
I'm listening. Oh, I can't hear her. Abdina, which object is slowing down? Abdina.
Sir, I'm on the go.
All right.
Sir.
My ladies.
Sir, please, do you say Abdina or Abina?
But Jesse,
I'm on the go.
take over. Jesse, which object is slowing down?
Yes.
Hey, Gerard.
Object C.
Gerard.
Sir.
Oh, I cannot hear you. Is it a problem from my end? Oh, okay.
Sir, please, object C.
Hello, Gerard.
Sir. Please, object C.
Object C.
Yes, sir.
Okay, I think I had issue at my end. Object C is slowing down, it's true. Now, Johnny says, which object was neither accelerating nor decelerating? Gerard.
Sir, object B.
Object B, 0 speed. So it is neither accelerating nor decelerating. Thank you. Which object travel the greatest distance in the 3-second interval? Which object traveled the greatest distance in the 3-second interval? Here you can use visual judgment. Frank.
Please, object C.
Object C. Yes. The contest is between objects C and D, but when you look at it, D is the largest area, and so the distance there will be greater. Which object had the greatest acceleration? Which object has the greatest acceleration? Elikem. Elikem.
Sir,
Yes.
please, A.
The greatest acceleration. All right. So once it's about acceleration, then it means the contest is between A and what? Class A and what?
A and D.
A
and D.
So let's calculate. Let's calculate the acceleration of A and then D. All right. So acceleration of A, we have the slope. Acceleration is equal to the slope of the graph. So changing the speed over change in the time. And we have maximum speed 30, minimum speed 0, over the change in time. We have 3 minus 0. So this is equal to 10 meters per second squared. Then the acceleration of D, the maximum speed is equal to 30. The minimum speed is 10 divided by the same time interval 3. Therefore, this is 20 on 3, which is 6.667 meters per second. So it is obvious object A has the greatest acceleration. 29. Compared with the average velocity of object A, the average velocity of object D is it less, greater, or the same? Class.
Greater.
It is greater.
You think it's greater? Okay.
Greater.
Let's calculate the average velocity of object A. So average velocity, once it's a uniform accelerated motion, the average velocity would be initial velocity plus final velocity divided by 2. This is equal to 0 plus 30 divided by 2, which is 15 meters per second. Then average velocity of object D, 10 plus 30 divided by 2. This is equal to 20 meters per second. So it means that when you compare, the average velocity of object D is greater. Yes, you were right. Class, this is the simple question I gave to. You see, another way of determining the same average velocity, the average is also total distance over total time. So we can also use this one. If we use this for object A, the area would give us the distance traveled, and this area is triangle. Half base. The base is 3. Then the height is 30. So we have, this is 15. 3 times 15, 45. So it's 45 meters. Therefore, the average velocity would be equal to 45 divided by a time of 3. Please, what is 45 divided by 3?
15, sir.
15.
So the value is the same as when we use this. Then for object D, the area is a trapezium. Have A is 10, B is 30. The height is 3. So we have, this is 40, 2 goes into this 20, 60, totaling 60. Total distance, right? So 60 divided by 3. What is 60 divided by 3?
20, sir.
Is that
20.
Is that 20?
Yes,
Yes,
please.
sir.
All right. And so it is also giving us the same value. So whichever way we look at the question, we must get the same answer. Please, any question, class? Any question? No question. Okay, Giovanni.
Sir, please, why did you subtract the 30 from the 3 when you were dealing with the parallel side A plus B?
Oh, half area of a trapezium, half plus B times the height. And so from 0, A is from 0 to 10. Okay, and B is from 0 to whichever last. Don't forget the shape. Am I answering your question? Giovanni, am I answering you?
Yes, sir.
So this is the shape. This is A. This is B. When you look at the drawing, the shortest side is A, and that is 10. Then B is the whole base. This whole base, which looks like this. And that is 30. So I don't need to subtract. I'm not looking for the difference. It's just the whole of B. Are you okay?
Yes, sir.
Please, is there any other question? I think Benjamin too has his hand raised. Benjamin. Oh, it's
Sir,
a
please,
mistake. It's a, hey, your mistake, you must solve it. All right. Let's delve into using equations of motion and sketching maybe this velocity time graph for a particular motion. Please, I'm reading a question to the house. Get ready to write it for me. A particle start from rest. A particle start from rest. And accelerate to a velocity of 5 meters per second. A particle start from rest and accelerates to velocity of 5 meters per second in 20 seconds. It maintains this velocity for 10 seconds and then decelerates to rest in a further 10 seconds. I'm going over. A
Yes, sir.
particle,
Please.
a particle starts from rest and accelerates to a velocity of 5 meters per second in 20 seconds, and then accelerates to a velocity of 5 meters per second in 20 seconds. Then it maintains this velocity for 10 seconds and then decelerates to rest in further 10 seconds. It maintains this velocity for 10 seconds and then decelerates to rest in further 10 seconds. All right, the first question is that draw a velocity time graph. Instead of draw, let me use sketch. Sketch a velocity time graph of the motion. Sketch a velocity time graph of the motion. Then two, the II question. Calculate the initial acceleration of the particle. Calculate the initial acceleration of the particle. And the total distance covered. And the total distance covered. So the II question is a 2-in-1 question. You are determining the initial acceleration and the total distance covered. So class, I'm giving you 6 minutes to work this out. Try it. Try solving the question, okay, on your own. Then after that, we all discuss to know our up and downs. You got it? Class, is that okay?
Yes, please.
All right. Start. Problem of the day. Of the moment. Whilst I take notes of attendance. Honorable members. Benjamin, keep quiet. Mute yourself and work.
Eko mepe ni ho phone.
Deborah. Elkume is coming here. You have 3 minutes to go. 3 minutes more. Our time is up. Hello, class. Our time is up. Please, were you able to solve it? Hello. You haven't finished.
No.
Okay, so 2 minutes more. Use 2 minutes. That 2 minutes, extra 2 minutes to go through it. Then we discuss it generally. Okay, so Oheneba Jenfi Samed, I've received your work. Okay, we'll go through it together. So if there are any, shortcomings, you can correct. Okay. Anita, are you here?
Yes, please.
Thanks for your earlier message.
Okay, you're welcome.
It was a very important reminder. All right. Time is not on our side, so let's go through it. So a particle starts from, I think I muted. Let me resume recording. A particle starts from rest. In kinematics or motion question, if you are told that a certain motion starts from rest, then it means the initial velocity is equal to 0. So this goes for starts from rest. Okay. Then if you are told that the motion comes to rest, if it comes to rest, then final velocity is 0. So comes to rest, or comes to a stop, then final velocity is 0. So these are key information you must actually pay attention to. So a particle starts from rest and accelerates to velocity of 5 meters per second, meaning when its initial velocity is 0, it increases speed gradually till it attains a final speed of 5. So the change in speed is actually from 0 to 5 meters per second. And this occurred within a time interval of 20 seconds. Okay. Then the second, so this is the first part of the motion. First part of the motion. Then in the second part of the motion, we are told that it maintains this velocity for 10 seconds. This final velocity of 5 meters per second is maintained. So initial 5 through to final 5 for a period of 10 seconds. And this is the second part of the motion. The second part of the motion. Lordina, are you here? Lordina. All right, then the third part, and then decelerates to rest in further 10 seconds. So this final velocity of 5 in the second part of motion reduce gradually. So when the final velocity is 0, when the final velocity is 0, the body is said to have come to a stop. And this also took place within a time interval of for further 10 seconds. And this is the third or the final part of the journey of the motion. So when a question is given, take your time and then divide it into parts gradually. Okay. Now, we are asked to sketch a velocity time graph. So pay attention and look at the sketch. My vertical axis was the velocity. Then the horizontal axis is the time axis, or is for time. Vertically, this is velocity meter per second. Horizontally, the axis, this is time, t/second. My velocities begin from 0, and the maximum velocity the body had during the entire motion is 5. So this is 5. Times were in 3 parts. The first time, 20 seconds. I'm sketching, so this is 20. The next time is 10. The time axis on the vertical and then the horizontal axis is both, the values are cumulative, they add on. So during the first part of the motion, a time of 20 seconds was used. During the second, time of 10 seconds. So I add 20 and then 10. So this will be 30, so that the interval will be 10. Then during the final part of the motion, extra 10 minutes was used. So that's 10 minutes plus 30, 40. So each stage must give you the time that was used. So in sketching my graph, this time is when the body accelerated uniformly. So the body starts from rest, accelerated uniformly to a velocity of 5 meters per second within a time of 20 seconds. This is the uniform accelerated motion of the body. Class, is this part understood?
Yes, sir.
Hello? Then this velocity was maintained for further 10 seconds. So within this time interval of, I'm coming. Within this time interval of 10 seconds, the body maintains its velocity. So once the velocity is maintained, then the gradient is 0. There's the second part of the motion. Then the third part, the body decelerates uniformly, so it comes to a stop for further 10 seconds. This is the velocity time graph. This is the velocity time graph. Let me see by hand those of you who got this sketch correct. I need to see more hands. So okay.
Sir.
Oh, awesome, awesome. That's good to see. A lot
Sir.
of you. Thank you. Then let's go to the calculate the initial acceleration of the body. Okay, so whenever you have a velocity time graph, the slope of it must give you the acceleration of the body. So since this is the first part of the motion, 1, 2, 3, the initial acceleration must be the slope of this part. Everyone say this is 0 or O, A, B, C, yes. So slope OA, determine the slope, OA, and this is slope is equal to the change in the vertical V over the change in the horizontal, which is the time. So 5, maximum velocity 5, minimum velocity 0, divided by 20 minus 0. So I have 5 on 20, and 5 on 20 is equal to 1 over 4. 1 over 4 is 0.25 meter per second squared. How many of you got this? Let me see you by hands.
We got.
I need plenty hands. So okay. All right. All right. Thank you. Those of you who couldn't get it right, please, I'm sure you are identifying your mistakes. Class, is that it? Talk to me. If you are noticing where you went wrong, that is what is important. Giovanni, your hand is up.
Sir, it's for the time
It's a mistake.
No, sir. Because I have a question. Hello. Sir.
Giovanni.
Sir, please, for the time graph. if you are sketching it, say please mine, I made on the vertical scale, I made it from 5 to 25. So I'm asking if you do that and you still manage to get the initial velocity and the distance covered, will it be accepted?
So, Giovanni, the time that the velocity given to us, okay, maximally, what we have in there is 5. We are told it starts from rest, accelerated uniformly to 5. Then the velocity was maintained for a period of 10 seconds. Then, so you must have within the vertical axis the minimum velocity and then the maximum velocity during the whole motion. So you can't have 25 in there. Are you okay?
Yes, sir.
So you must do it as I have done. All right. Then the total distance covered during the motion. The total distance covered during the motion. I just want to clear this part so that I use a sketch. Area under the velocity time graph would give you the total distance traveled. Okay, and so this shape gives us a trapezoid shape, a shape of a trapezium. So the area of the trapezium area must be equal to the total distance traveled. So determine the area of the trapezium, which is half A plus B times H. Half, what is A? A is just two parallel sides, this side. So OA, AB, and OC. AB is 30 minus 20, which is 10. Then B is this. The whole represent the whole time. So 40. H is the perpendicular side. The side which is perpendicular to both A and B. And that is 5. So we have half times 50 times 5. This is equal to 2 goes into 50, 25. So we have 25 times 5, which is 75 meters. How many of you got this correct?
Sir, please, 25 times 5 is not 75.
Okay. Oh, 125. Yeah, I'm tired though. Okay, thank you. It's 125. 125 meters. How many of you got it? Please show by hands. Just 4 hands, 6. I'm counting also. All right, so 9, 11. Okay. All right. So please, if you couldn't get it, please identify where you went wrong and then correct it. Okay. And don't forget, you can also use the individual areas. This is a triangle. Half 20 by height, which is 5, plus the rectangle, which is 10 by 5. 10 times 5 plus the other shape is triangle, another half base, which is 10 times height, which is 5. when you put this together, this goes into this 10. So this is 50 plus another 50. This goes into this 5. So plus 25. In all, you have 125 meters. The value is still the same. Emelda,
Sir, please, the A, why is it 10? I thought it was supposed to be 30 rather.
so this is the length A. This is the length A. Let me clear the two, representing the second part of the motion. This is A. And then B is from this side. This side to this side. So,
So
Emelda, if I'm looking for this distance, how would you calculate it? You from the 0 to this point is 20. From 0 to this point is 30. So if I need this, just this distance, how would you calculate it? Imelda.
the 30 minus 20.
Exactly. So that's 10.
Sir, but I thought it was supposed to be from 0 to 30. That would be the A. Because it starts from here.
No,
There.
for parallelogram, okay, it is the two parallel sides. This side is parallel to this side. And the height must always be perpendicular to both parallel sides. So which can be this or this. Okay, so it is not from here to here, to this point, but it's just these two parallel sides, the smaller one and then the bigger one. Are you okay?
Sir, so for all of them, that's how you calculate it.
Yes,
And the previous ones we did.
exactly.
Okay.
Is there
Thank you.
from Poma? Okay.
It was a mistake.
Okay. Now you see, we can also use the equations of motion to do the same thing. We can also use the equation of motion to calculate for the same thing. But here you must divide it into parts. First part of the motion, second part of the motion. The first question requires that we calculate the acceleration of the initial acceleration. And using equation 1, V is equal to U plus AT. Okay, let me open the next page. But I'll be referring to the diagram. So using equation 1, V is equal to U plus AT, we can find the acceleration. A is equal to V minus
U.
all on T.
Yes.
Okay. What is V? V is 5. What is U? 0.
0.
Divided by 20. And we are still having 0.25 meter per second
squared.
Yes. So we can also use the equation, but usually this question restricts us to using the graph. Then we are to calculate the total distance and look at it. During the first part of the motion, we can use S is equal to UT plus half AT squared to find the total distance during the first part. Of course, the motion starts from rest, so U is 0. If U is 0, this whole part goes to 0. So we have half times A times T squared. And so the total distance traveled during the first half is equal to, the acceleration is 1/4 or 0.25. The time used 20 seconds squared. So we have 1/8 times 20 squared is 400. Divide 400 by 8, and the answer is 50 meters. So we are getting the same results just as what we got using the area of this triangle. A, B, C. When we use the area of the triangle, we had 50. Equation of motion 50. Now the second part, the speed is maintained. So initial speed during the second part of motion 5. Final speed during the second part of motion also 5. Acceleration. What is the value of acceleration here, class? What's the value of acceleration? During the second stage, second part of the motion.
0.
0. Time used 10. So using v squared is equal to u squared plus 2as. Acceleration, because acceleration is 0, this will not help us determine s. But when we use s is equal to ut plus half at squared, this part will go to 0 because a is 0. So the distance traveled will be u, which is 5, times time, which is 10. We have 50 meters. And this is the same as what we got when we use the area of the rectangle. Length 5, length 10, and then width 5. We got 50, the same value. Okay. Class, are you following? During the third part of the motion, we are told that the body decelerated uniformly. So u is equal to 5. So it came to rest. V is equal to 0 within a time interval of 10. So using v squared is equal to u squared plus 2as. We have u. U is 5. V is 0. We don't know the acceleration, but we can calculate for it. Okay. So let's calculate for the acceleration, the deceleration. V is equal to u plus at. V is 0. U is 5 plus a is not known, but the time is 10. Therefore, a equals minus 5 over 10, which is minus 0.5. Therefore, this is 0. This is 5 squared minus plus 2 times negative 0.5 times s. So we have 25 minus s, because 2 times half is 1. Therefore, s is equal to 25 meters. So at all the stages, these are the distance traveled. When you add together everything, you have 50 plus another 50 plus 25. And that is equal to 125 meters. Please, any question? Any question before I have Imelda?
So each of the parts, did you deduce them from when you were stating the a particle starts from rest 0
Ex-
to
Exactly.
5?
Exactly. So listen to how I determine each of the parts. A body starts from rest and accelerates to a velocity of 5 meters per second in 20 seconds. This ends the first part of the motion. A body starts from rest and accelerates to a velocity of 5 meters per second in 20 seconds. Then listen to the next part. It maintains this velocity for 10 seconds. So this velocity, which velocity? 5 meters per second is maintained for 10 seconds. Second part of the motion. And then decelerates to rest in further 10 seconds. So when you listen to the question, you can deduce the various stages of the problem. Are you okay?
Yes, please. So you replace the acceleration with the deceleration at the last part.
You see, deceleration will simply be negative.
So minus the actual value for the acceleration.
Sometimes not the same value. Let's use the graph to calculate for the deceleration. Class, pay attention. So the slope of this OA gives us the acceleration. The slope BC must also give us the deceleration. And look at how I'm going to calculate it. Acceleration is equal to final change in velocity. So final velocity minus initial velocity divided by time. For the part BC, what is the final velocity? Emelda, what's the final velocity for the motion BC?
5.
No, final.
0.
Pardon? Class, what's the final velocity for the third part of the motion?
0.
It's 0, because we were told that then the body decelerates, so it comes to rest. So when it comes to rest, it means final velocity is 0, and that is when the graph hits or intersects the time axis. Okay, so final velocity is 0 minus initial velocity during this part is 5. So 0 minus 5 divided by, what's the time interval during the deceleration? 10. So we have negative 0.5. So Imelda, is not the same as, you don't just negate the acceleration as deceleration. You must calculate. Okay.
Okay.
All right, class. Another question for your trial. Then, just to cement your understanding. A motorcycle, Ada.
Please, I have a question.
All right.
Please, when you are finding the acceleration of the third part, yes, you wrote B is equal to U plus AT. And I don't understand how you were able to send the A to the other side of the plus sign without the 10.
That's what I wrote. All right. Now, in using this, it's about the third part of the motion. Either, what is the final velocity of the body? During the motion, what's the final velocity of the body? That is 0. We are told the body comes to a stop or rest. Okay. So V is 0 because the body has come to a stop or rest. What is the initial velocity just before the body started to decelerate? What is the initial velocity of the body just before it began to decelerate?
5.
5. So U is 5. plus all these
Accelerate.
all this deceleration occurred within 10 minutes. So time is 10. So
Okay.
just look for A. But the moment your value of A is negative, then it means it's a deceleration.
Okay.
Okay. So when you look at it, we have, when you send 5 to the other side, you have minus 5 is equal to 10A. To determine A, you divide through by 10, isn't it?
Yes, please.
And A is equal to negative 0.5 meter per second squared. And this implies that it's a deceleration.
Okay.
All right. Imelda again.
Sir, please, the formula for the deceleration you wrote there, isn't that the formula for the acceleration?
Good. It's a, you see, they have the same formula. The only thing is that if it's a deceleration or retardation, your value of A will be negative. That's all.
Sir, so it will be A is equal to V minus U over T, where A is equal to deceleration, V is initial velocity, and the U is final velocity.
No, U is initial velocity, V is final velocity.
Okay.
V is whether deceleration or acceleration. V is final, U is initial, and A is acceleration. But the point is that if you get a positive value for the acceleration, then it means the body was accelerating, just meaning that the speed was increasing with time. If you get a negative value, it's a decelerating, meaning that the body's speed was decreasing with time. Emerald, are you okay?
Yes, please.
Class, the rest of you, please, I hope you are following it.
Yes, please.
Okay.
Yes, please.
All right. One very last question. A motorcycle accelerates from rest. A motorcycle accelerates from rest for 10 seconds up to a velocity of 20 meters per second. A motorcycle accelerates from rest for 10 seconds up to a velocity of 20 meters per second. It continues with uniform velocity. It continues with uniform velocity for a further 20 seconds. For a further 20 seconds, and then decelerates so that it stops in 20 seconds. And then decelerates so that it stops in 20 seconds. A, sketch a velocity time graph for the motion. Sketch, Giovanni.
Service, can you take it again? My network is so good, so I'm not hearing it well.
A motorcycle accelerates from rest for 10 seconds up to a velocity of 20 meters per second. Up to a velocity of 20 meters per second. It continues with uniform velocity. It continues with uniform velocity for a further 20 seconds and then decelerate so that it stops in 20 seconds. And then decelerate so that it stops in 20 seconds. Calculate A. Sorry, A. Sketch. I'm including my own question. So sketch a velocity time graph for the motion. For the motion then B, calculate the acceleration.
Sir, please, is that all?
Calculate the acceleration. Then C, the deceleration. The deceleration. Then D, the distance. Calculate the distance travel.
The distance.
So you are doing all this using the graph. So use the graph to determine all this. Benjamin,
Sir, please, you said the distance.
then I'm listening. Oh.
Yes, sir. Sir, please, you said the D. I didn't hear you.
The D, the distance traveled. Calculate
Yes,
the
sir.
distance traveled. Please, I've written the questions on the board, so check from the board. Okay, so make me proud. How many minutes? How many minutes? Giovanni,
Sir, please, can you repeat the time values, like the seconds you
so
mentioned?
the first time a motorcycle accelerates from rest for 10 seconds up to a velocity of 20 meters per second. And then, Benjamin, please mute yourself. I'm coming in. It continues with uniform velocity for further 20 seconds. So first time 10 seconds, it continues with uniform velocity for further 20 seconds. And then decelerates so that it stops in 20 seconds. In 20 seconds. So this is the time during the first part, second part, and then the third part. Giovanni, are you fine?
Yes, sir.
Benjamin, your hand was up. Or it's a mistake? All right, so let me give you about 8 minutes. 8 minutes for this exercise. Whilst I take note of attendance. You have 3 minutes more. Three minutes. 3. So, Gideon, I've noticed your solution. We'll discuss it, okay? Jesse, I've also noticed what you said. Priscilla, are you here?
Yes, sir.
Okay. Do we discuss it?
Yes,
Or you still want to look at it? Do we discuss it?
yes.
Yes, please.
All right. Hey, Priscilla, sorry, Prof. Priscilla. Prof. Priscilla, are you here? Okay, so I'm coming. All right, so let me clear this part. In fact, you have made me proud. So let me clean the make me proud a statement. Okay, so a motorcycle accelerates from rest for 10 seconds up to a velocity of 20 meters per second. It continues with uniform velocity for a further 20 seconds and then decelerates so that it stops in 20 seconds. Calculate the acceleration. Sketch the velocity time graph. So let's sketch the velocity time graph. So my velocity axis then the time axis. Let's label the axis velocity v/meter per second, then time t/second. The maximum velocity is from rest, then accelerates from 10 to from 0 to 20. It maintains this velocity for a further 20 seconds and then decelerates so that it stops in. Okay, so the maximum velocity is 20. So maybe from this is 0, 10, and then 20. 10 is just a fluke because we will not use it in our calculation, but then the time, 10 seconds is used. Then another 20 seconds. I must estimate this 20 to be greater than the 10. So if this is 10, then this was 20. So 10 plus 20, 30. Then decelerate so that it stops in 20 seconds. Another 20 seconds. So I'm just estimating based on the value. So 20 plus 30, 50. Okay. So let's go to the sketch of the graph. It accelerates uniformly to a velocity from rest to 20. So let me connect this time to velocity of 20. So this is where the body accelerates from rest. Then, so it attains a velocity of 20. This is the first part. This is shifted a little bit. Let me undo and redo. So from 0 here, oh, okay, then the velocity is maintained for further 20 seconds. So this velocity of 20 is constant. So when you check the interval is 20. Then decelerate till it comes to a stop. For another, there's a graph. And I'm sure most of you had this correct.
Yes.
Yes. So then the question, calculate the acceleration. This is uniformly accelerated part. So O, A, B, C, D, E. So the acceleration is the slope OA. So the slope is equal to change in the vertical 20 minus 0 over 10. And this is equal to 2 meters per second squared for A. Please start marking yourself. So then B, calculate the deceleration. The uniform deceleration will be slope of BC. Okay. So the slope of BC is equal to final velocity 0 minus initial velocity 20 divided by a time interval of 20. So this is equal to -1 meter per second squared. This is actually C. A is this. A, B, yes. Then the D part, total, the distance traveled is the area under the velocity time graph, this whole area. Then during under the first part of motion, second part of motion, one, second part, then the third part. The whole area under it would give us the total distance traveled. Therefore, this shape is the shape of a trapezium. So total distance equals the area and the graph. This is the area shape of a trapezium. So half A. What is A? AB. Yes. What is the value of A? The shorter part of the spiral size, and that is 30 minus 10, which is 20, plus B. What is B?
$90.
No, B. I mean B. B is 50. Don't forget this is 10 plus 20, 30. 30 plus another 20. So the total distance traveled is 50.
Okay.
So H is 20. Therefore, we have half times 70 times 20. This goes into this one. So we have 700 meter. Okay. You can also confirm the same thing by considering area, this shape of the triangle during the first part. Pick the second part. This is half. The base is 10. Height is 20. So this is equal to 100. During the distance traveled during the first part. Then during the second part, length of the area of rectangle, the length is 20. And then times another 20, giving us 400. Then this area again of triangle again, half the base is 20
times 20.
Yes.
Times
another 20. Okay. So this is also 200. When we add, we have
700 meters.
700. So the value is the same. Okay. You can also play around using equation of motion. For the first acceleration, V minus U all on T. V is 20, U is 0, T is 10, 2 meters per second squared. Then distance traveled, S will be equal to half AT squared because U is 0. Therefore, half A is 2 times 10 squared. This and this, 10 squared is 100. So this is 100. Then second part of motion, okay, S is equal to UT. Says acceleration is 0. So U is 20 times T is another 20. This is 400. I'm using UT. S is equal to UT because the half AT squared will be 0 because acceleration is 0. Then during the other part, if V is 0, U is equal to 20. What's the acceleration? Acceleration is equal to 0 minus 20 divided by another 20. This is minus 1 meter per second squared. All right. Therefore, we'll have S being equal to UT and U is 20. What is T? T is 20 minus or plus half. A is -1, then 20 squared, T squared. That's 400 minus 100 minus 100, and that's equal to 300. Another way out can be using V squared is equal to U squared plus 2AS. V is 0, U is 20 squared plus acceleration is -1. S is what we are looking for. So -2S, we have, when we send this negative to the other side, we have 2S is equal to 400. This is 400. 400 and A is 0. If A is 0, sorry, A is -1. So when we take it to the other side, we have 2S. S is 200. Why? What is wrong? I want us to use this formula. Let me look at it well. Plus 2AS. Final velocity is 0. Initial velocity is 20. So 20 squared plus 2 times acceleration is -1 times S. So -400 when it crosses to the other side is equal to -2S. S is equal to positive 200. Why is it different from this? I'll check and then find out. So whichever way you look at it, you must get the same thing. Class, is that okay? Yes, Emelda.
Sir, please, when you're using the equation of motion to find the total distance, is it necessary to follow
Emelda,
like,
yeah.
is it necessary for it to start like the S equal to UT plus 180 square over 2 first before you move to the V is equal to
No, it
U?
depends. It depends on information you have. Is that the information? You see, there are some equations that cannot be used depending on what and what you have. Okay. So you can use any, but it depends on the information at your disposal. Some of the equations are such that you need to use maybe the first one or second one to find one quantity before you can use that to find. Imelda, is that okay?
Yes, so it means one variable should be left.
In some of them, one variable wouldn't be known. So you must use one to find before. Example, You see, in calculating for distance, when I use s is equal to ut plus half at squared for this, for the third part of motion, I have u, I have t, but I had not calculated for a, so I use equation 1 to find a before substituting it here to find x. Are you okay?
Sweet.
Please, if there is no question, then we call it a day. Okay. It's been nice having all of you. As usual, I'll send sample questions for you to try. All right. So, in fact, we end it here for today and for the week. Bye-bye.
Bye.
Okay.
Bye.
Bye-bye.
Bye.
Bye.
Yeah. Don't forget to subscribe. Oh. I've noticed you've been doing it, but continue doing it. I ask IS to give me more money. Hey, Prof. Priscilla.